Hi guys, in this video lesson we're going to talk about applying quadratic functions. So you've seen quadratic functions in three forms: standard form, factored form, and vertex form. And you could easily multiply out something in factored form to put it into standard form, or double distribute, multiply by a, and add k to put something in vertex form and standard form. But really all the application we look at when it comes to quadratics is largely in standard form. So my favorite kind of application for quadratic functions is vertical motion, partly because I extend this in calculus, and I think it's fun to see the connection, but really it's a good visual for everyone. So in this example, suppose a rock is dropped from the top of a 20-foot ladder. The equation for vertical motion is given by h of t equals negative 16 t squared plus v sub o t plus h sub o. So we're going to write an equation to represent this situation, but before we can write an equation, let's talk about what each of these variables represent. H of t is height in terms of time, and you might even seen some notation like this in science class before, especially if you've taken physics. Lowercase t is for time. If you ever see uppercase t, it'd be temperature. And then v sub o is actually v sub 0, and it means what is the velocity when time is 0. An easier way to say that, though, and what you'll normally see in story problems, is initial velocity. What's the velocity to start? And then you have h sub o, which is what's the height when time is 0? Or this most simple way to say it is, what's the initial height? What's the height before the object started moving? So to write an equation for this, you're just going to plug in the nodes. So h of t is always going to be there. Negative 16t squared, as long as we're talking about things in terms of feet, is always going to be there. And in this case, v sub o is 0 because we're dropping it. And h sub o is 20 because we're dropping it from a 20-foot ladder. But we could simplify this a little. We could just say, well, 0 times t is just 0. So this is my equation. Negative 16 t squared plus 20. I'm going to write that down quick because I know you can't see that last slide. And this is part B, and it says for the same example, what would the height of the rocket be after half a second? So since our time is in terms of second, we're just going to plug in a half. This is one of the first times this year I'd say go for using your calculator. So when I type this in the calculator, I type it in exactly as I see it. Negative 16 parentheses 0.5 parentheses squared plus 20. Type it in exactly as you see in the calculator and you'll get an accurate answer out. And this comes out to exactly 16 feet. This is a nice clean one. More often than not, they're going to have decimals in them. This question says, how long will it take for the rocket to hit the ground? So the rocket hits the ground when the height is 0. So rather than h of t, I'm going to replace that with a 0. Now you could solve using a bunch of different methods we learned. You couldn't factor this one. There aren't factors of negative 16 times 20 that add to equal 0, or at least not that I can readily think of. You could use quadratic formula. You could complete square, but it'd be a little weird because there's no b term. Or you could just use square roots. And I think square roots is probably the most straightforward for most of you. So you could move either the 16t squared or the 20 to the other side. And then you're going to divide by 16. So I just rewrote that so it was over here. A little more clean. And then take the square root. So on my calculator, I'm going to do second square root button, 20 divided by 16. And I'm making sure I'm taking the square root of the whole phrase, that whole mathematical expression, 20 over 16. And when I type it in, I get t is approximately equal to 1.118 seconds. And in math, unless it's an integer or something that truncates nicely like 1.5 or 2.25, we're always going to leave 3 digits after the decimal. So 1.118 seconds. If you take AP Calc or AP Stats in a couple years, this is standard. It's always 3 numbers after the decimal. Okay, example 2. Suppose a model rocket is launched from a platform 12 feet off the ground with an initial velocity of 200 feet per second. The equation for vertical motion is given by h of t equals negative 16t squared plus v sub o t plus h sub o. So just like in that last slide, I'm going to quick review with you. H of t means height now, height in terms of time. So after a certain value of time, t, lowercase t that is time. In this problem, it's in seconds. V sub o is the velocity when time is equal to 0, which could be more simply just said initial velocity. And I'm sure in a science class at some point you've had to identify your variables, so this is probably not new to you. H sub o is height when the time is equal to 0, or initial height. So I'm going to get h of t equals negative 16 t squared plus, let's look, model rocket is launched from a platform 12 feet off the ground. So I know that's my initial height with an initial velocity of 200 feet per second. Now, sometimes it'll be a negative velocity, but they will clearly define if it's a downward velocity. So plus 200 feet plus 12. So just rewriting our equation so we know what we're working with. And in part B, it says, what is the height of the rocket after 2 seconds? So I'm just going to plug 2 in for t. And I'm going to type it all in my calculator exactly as I see it. Negative 16, parentheses 2 to the second, plus 200 times 2, plus 12. And I get a nice clean 348 feet. You know, it seems high, but you're starting at 200 feet, or sorry, you're starting at 12 feet, and your initial velocity is 200 feet per second. So it's going to get pretty high pretty quickly. So we're still using that same equation that we wrote in part A, h of t equals negative 16 t squared plus 200 t plus 12. This question says, how long will it take for the rocket to reach its maximum height? So sometimes it's a good idea to sketch a picture. You could have earlier, but if you know it's launched from 12 feet, and we know it's going to go up and come back down. It's not very symmetric. Let's try that again. Because this is a quadratic, it's going to be symmetric in nature, but part of it might be off the graph, like in this one. So don't just say, oh, under the ground and divide by 2. It's not always even like that if you have a launching value greater than 0. So we want to know what this point here is. So this point here, this is time in terms of seconds, and this is height in terms of feet. So this little point here would be time and height. And we know this point. That's just another just a vertex. And this is just an axis of symmetry. So if I want to know how long, I'm just going to use the axis of symmetry equation. And I'm going to say, okay, so t in this case, because that's the dependent variable, is negative b over 2 times a. So I'm going to type in, and you might need to be careful with parentheses depending on the calculator you're using, but negative 200 divided by negative 32, because 16 times 2 is 32, and I get a nice clean 6.25 seconds. So in this problem, it says what is the maximum height the rocket will reach? So if you look back here, we know this is giving us our maximum height, right? So we just need to figure out what is this y part of our vertex, because that's the maximum height. So I'm going to take that 6.25, the axis of symmetry I just found, and plug it into my equation. So I'm going to say h of 6.25 equals negative 16 times 6.25 squared plus 200 times 6.25 plus 12. And then just like I did previously, I'm going to type that in the calculator just the way I see it. Nothing fancy there. And I end up with a nice clean 637 feet. In this question, we still have that same equation that we've been working with for the last few slides, because we're still on example 3. It changed from 2 to 3. Silliness, it's still example 2. Plus 200t plus 12. So the question says, how long will it take for the rocket to reach the ground? So if we think about that image we drew earlier, we had a platform, it goes up, it comes back down. It's going to hit the ground when it hits the x-axis. So it's going to hit the x-axis when height is 0. So there probably aren't factors of negative 16 times 12 that add to equal 200. It could complete the square, but it might result in some pretty big numbers. Can't use square roots because I have a b term, but I could use the quadratic formula. I could say t equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. And especially since the numbers are so big here, I would recommend going ahead and finding your discriminant. And then when you go to put this on a calculator, and I'm actually going to erase a pretty little drawing here, make some room. You're going to put in two things. You're going to type in negative 200 in parentheses plus square root of 40,768 parentheses divide by negative 32. So let me take a second to do that. And that gives me this weird time of t being approximately equal to negative 0.059, or if we round it up, it would be 0.060. And then we'll do the negative version. And remember, there's a great trick that if you hit second enter, you get exactly what you just typed in and you can type over it. You don't have to retype everything in. And this time, you get t is approximately equal to 12 point, and you can either do 5.559 if you want to truncate, or 0.560. Now, this is the logical answer. And let's think about that first answer. First of all, negative time doesn't seem logical. Let's talk about where it comes from. If you go back to that picture, that negative answer is over here, and that positive answer is over there. Okay, geometry. So for some of you, that's good news. Some of you, less good news. But either way, geometry, the nice thing is you have a picture. So the width of a rectangle is 6 meters less than its length. So let's draw a rectangle. So this is the length, and this is the width. The width is 6 meters less than the length. Okay. And then they tell us that the area is 112 meters squared. Find the dimensions of the rectangle. Well, I know the area of a rectangle, and I bet you do from geometry too. Area is length times width. So I can say, well, area is just 112. Length I don't know, but I know width is equivalent to length minus 6. And that's helpful because then you're going to get L squared minus 6L. If I move everything to one side, then I can either look for factors of negative 112 that add to equal negative 6. They might exist. I could complete the square. I couldn't use square roots because I have a b term, or I could use the quadratic formula. So L equals negative b plus or minus square root b squared minus 4ac all over 2a. And then again, like before, it's a good idea to go ahead and find your discriminant value. You're a little less likely to make your mistakes if you do that part first. So square root of 484. So I'm going to say 6 in parentheses. I'm going to do 6 plus the square root of 484 divided by 2, which that gets me 14. That seems like a valid option. I hit second enter and I change that plus to a minus. I get negative 8. And that doesn't seem like a very good option for a length. So I can say the length is 14 meters. And if we know the width is 6 less than the length, right? The width is just 14 minus 6. So in this case, that would be 8 meters. This problem you might be able to guess and check yourself that far, but a lot of problems it doesn't come out that well, especially if it's a decimal. Example 4. The dimensions of a rectangle, so I'm going to draw a rectangle again, are x plus 6 and x minus 2. If the area is 65 inches squared, find the dimensions of the rectangle. So again, think about what you know. What is the area? Now, what is the equation for the area of a rectangle? And then now we're going to take those two pieces and put them together with what we're given. So we know in this problem the area is 65 inches squared. And we know generally speaking the area of a rectangle is length times width. So we're going to replace area with 65. And we're going to say our length and width are x minus 2 and x plus 6. So then I'm going to double distribute these out and move everything to one side. So negative 12 minus 65 is negative 77. And if you can think of factors of negative 77 that add to equal 4, so like in this instance, I can think of 11 and negative 7. You could factor, you could complete the square. Again, you can't use square roots because there's a b term. But once you know those, or you could use quadratic formula, of course, then you're going to get, well, x equals negative 11, x equals 7. But negative 11 doesn't seem like it's going to go so well for us for a dimension. So then you look at each part of your rectangle and you say, well, this one side, we'll call that our length, x minus 2, so it's 7 minus 2, which is 5 inches. And then the width is x plus 6. And then in this case, x is 7, so 7 plus 6 is 13 inches. Those are your dimensions. Okay, next example. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. So let's see, we've got a long side and short side. So let's see, we'll call our shorter side x. And it says the hypotenuse, that's this side, right? Hypotenuse is 1 foot more than twice the length of the shorter side. The longer leg is 7 feet longer than the shorter side. Find the dimensions of the triangle. So think back to geometry. What do you know about this type of triangle? So you did a lot with right triangles. You know that what you learned in geometry. A squared plus b squared equals c squared, right? And you know a is one of the legs and b is another leg. So if I replace a with x and b with x plus 7 and c with 2x plus 1, see what I get. I'm going to get x squared plus 14x plus 49. And then over here, I'm going to get 4x squared plus 4x plus 1. Now I'm going to combine like terms. So x squared and x squared is 2x squared, 14x, 49. Now I'm going to move everything to one side. So I'm going to get 0 equals 4x squared minus 2x squared is 2x squared. 4x minus 14x is negative 10x. And 1 minus 49 is negative 48. So again, I can go through my strategies. I can't use square roots because I have a b term. I could complete the square. I could use quadratic formula. Or I could use factoring. So I'm going to try factoring. Let's see if that works for me. If I pull out a 2, I'm going to get x squared minus 5x minus 24. I say, what are factors of negative 24 that add to equal negative 5? So negative 8 and 3. So that means x equals 8 and x equals negative 3. Negative 3 does not seem like a good side length. I'm sure you can see that. Especially those of you that have done any sort of, geometry or building. So if x equals 8, that tells me this side is 8. It didn't give me any units of measure, so feet, inches, meters, I don't know, it didn't tell me. So I know this side is 8 because it's x. And then this side is going to be 2 times 8 plus 1, so 17. And then this side is going to be 8 plus 7, so 15. And if anything seems odd to you, you can always go back into the description and make sure it checks all the boxes. Okay, consecutive integers. Find 2 consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. So let's talk about that word consecutive. That's normally where people have problems. Consecutive is a fancy way of just saying in a row. And remember, an integer is a positive or negative whole number. And I think you know what odd and positive are. So let's kind of break this down a little. 2 consecutive positive odd integers. So if I call the first one x, the next one needs to be 2 bigger, right? Because odd numbers go from like 1 to 3, 3 to 5, or 5 to 7. So it's 2 bigger. So we need to find 2 consecutive positive odd integers such that the square of the smaller added to 3 times the larger is equal to 24. So x squared plus 3x plus 6 equals 24. Now when I move that 24 over, I get x squared plus 3x minus 18 equals 0, because 6 minus 24 is 18, well, negative 18. And then I'm looking for factors of negative 18 that add to equal 3. So x plus 6 and x minus 3. So then I get x equals negative 6 and x equals 3. Now, in my description, it specifically said that I was looking for 2 consecutive positive odd integers. So that means I can rule the negative 6 out. And I can say, well, if x is 3, then the next integer after 3 that is also odd would be 5. So my 2 numbers are 3 and 5. Now, those are so small you probably could have guessed and checked them if you're that kind of critical thinking person. But this is a process you'd need if those numbers were like 137 and 139. This is the general structure for consecutive integer problems. Now, if you want to check, you could say, well, if the square of the smaller, so 3 squared, added to 3 times the larger is 24. Yep, that checks. So you know you're on the right track. And you could always follow that checking process for any of these. You could say, do all of these dimensions add up to whatever was given on the screen? Okay, I'm going to read this problem, and then I'm going to have you do it. And I just noticed that this equation got separated in 2 lines. So just know it's a negative 16t squared. So this problem says a ball is thrown upward vertically from the ground with an initial velocity of 25 feet per second. Using the equation h of t equals negative 16t squared plus 25t, determine the maximum height the ball will reach. So take a second to think about what this picture would look like. So initial height 0, because I don't give one. Oops. So you're going to have something like this. Okay. So I want to know if this is my maximum point, time the height. So this is time in seconds. This is my height in feet. So to do this problem, I want you to think about, what do you need to find? Do you need to find the axis of symmetry, the vertex, or an x-intercept? Okay, so great. You know that in order to find this maximum height, you're going to need to know the vertex. But in order to find a vertex, you need to find an axis of symmetry first. So we're going to say t equals negative b over 2 times a. So if I do negative 25 divided by negative 32, I get this kind of nasty number. It's 0.781. And then to find the actual maximum height it's going to reach, I need to plug in the 0.781 into my equation. So I'm going to type it in exactly as I see it. Negative 16 times 0.781 squared plus 25 times 0.781. And I'm going to end up with 9.76, and then that 6 would round the 5 up, so it'd be 6 feet. Next problem. The length of a rectangle is 1 more foot than twice its width. If the area of the rectangle is 300 feet, find the dimensions of the rectangle. So take a second in your notes or whatever you're writing on to draw out this picture and label it to the best of your ability. Okay, so I'm going to draw a rectangle. It says the length of a rectangle. So if I call it, let's see, go this way. It says the length of a rectangle is 1 more than twice the width. I also know that the whole area is 300 feet squared. And I know that the area of a rectangle is length times width. So I'm going to start plugging in my knowns, just like you would like in a science class. Area is 300. Length is 1 more than twice the width. Now take a second. Go ahead and simplify and see if you can find these dimensions. So if you've gotten this far, you know that you can't use square roots because you have a B term. You could complete the square, but you'd probably end up with some fractions. You could use factoring or quadratic formula. I'm going to go ahead and use quadratic formula. We haven't done that much in these examples. So W equals negative B plus or minus square root of B squared minus 4 times A times C all over 2A. And if I find my discriminant of 1 squared minus 4 times 2 times negative 300, I get that my discriminant is 2401. And then when I make sure I put my whole numerator in parentheses, I get negative 1 plus the square root of 2401 divided by 4. So I get that W equals 12. That seems like a good option. If I hit second enter on my calculator, I can change that plus to a minus, and I get negative. That does not seem like such a good option. So I'm going to say my width is 12. So if my width is 12 feet, then I can plug that in to find my length. So my length is going to be 25 feet.